intrinsic feature of the universe since its very existence, its seemingly endless expansion. However, it is crucial to understand that the cosmos is not expanding into a void in space but that space itself is constantly increasing in size. If we follow conventional theories, it is estimated that the first stars began to shine between 200 and 300 million years after the Big Bang, marking the end of the so-called Dark Age when the first luminous celestial objects clustered together to form mature galaxies. However, how fast these galaxies grew is still an unsolved enigma. An important clue to solving this galactic enigma emerged through the first images captured by the James Webb Space Telescope in July 2022. Experts announced that the telescope had detected a number of galaxies, some of which had already existed some 300 million years after the formation of the universe. However, compared to the galactic structures that developed millions of years later, these early galaxies remained considerably smaller and less massive. This fits perfectly with the scientific model accepted by researchers. The density of matter in the young universe was simply not sufficient to give rise to galaxies the size of the galaxies we observe today. What began as a discovery of 6 bright redshift luminous spots apart from James Webb turned out to trigger one of the most significant astronomical crises of recent times. Now, although these newly discovered galaxies are similar in age to previous record-holding galaxies, they are almost as massive as our own Milky Way galaxy. This has presented an intriguing mystery through astronomical research. Thanks to a team from Swinburne University of Technology in Melbourne, after examining a series of images captured by the near-infrared camera, the experts finally identified the previously mentioned light sources. Using redshift, the scientists calculated that the light from these objects took more than 13 billion years to reach our eyes on Earth. Consequently, we are dealing with structures that had already existed between 500 and 700 million years after the alleged Big Bang. By analyzing the characteristics of these structures, it was concluded that the Webb telescope had captured 6 extremely early galaxies in the image. Surprisingly, these galaxies were so massive that they defied conventional expectations of cosmology. Instead of finding the expected dwarf galaxies, structures were identified that were almost as massive as our own Milky Way galaxy despite having formed at an early epoch. If we continue to analyze the data collected by the James Webb Telescope, this gravitationally bound grouping of stars was already more than 10 billion times the mass of the Sun at that time, and one of them may even have surpassed the 10 billion solar mass mark. However, even if this possibility is considered, the mystery is still not completely solved. Even in this scenario, there would be significantly more stellar mass in the early universe than previously assumed. This poses a puzzle since, shortly after the Big Bang, there was not enough normal matter available to form so many stars in such a short period of time. The detected objects contradict virtually all conventional cosmological theories. Even if only one of these galaxies turns out to be genuine, it would go beyond the limits of our previous assumptions to explain the existence of these structures. Furthermore, the density of matter in the early cosmos would have to have been up to 5 times greater than previously assumed in order to explain this phenomenon. Another equally mysterious explanation is based on the fact that these galaxies developed in a way that is still completely unknown to us. These discoveries and the debates surrounding the Big Bang are leading more researchers to move away from this theory. Many astronomers with more alternative views are frustrated that they are not being heard in scientific journals. Even those who express doubts about existing theories are often labeled as unfounded eccentrics. However, it is undeniable that even experts who still defend the Big Bang theory are constantly faced with questions without clear answers. These questions include particular issues such as why and how 13.8 billion years ago something literally came out of nothing. Can something really originate from nothing, or was there some triggering event, or was it just all a coincidence? Stephen Hawking pointed out that the concept of time as we know it began only with the Big Bang, therefore, this process could not have been triggered by something else or someone external. A similarly controversial question relates to the uniformity of radiation and density throughout the cosmos. No matter in which directions or at what distance we look on a larger cosmic scale, we find similar densities and distributions of galaxies, nebulae, and radiation everywhere. Conservative scientists explain this by the theory of cosmic inflation. However, other experts take this assumption and take it a step further with the theory of chaotic inflation. According to this idea, it is possible that this process has stopped only in some regions like bubbles and continues infinitely elsewhere. This implies that multiple universes form in these bubbles, each with its own individual physical laws. Considering this context, a fundamental question arises: what if the cosmos does not represent the complete whole, and even more, if another universe existed before ours? In that case, the Big Bang would become a great cycle. Following this theory, what we consider the beginning and end are ambiguous concepts in a cosmic context. What we usually refer to as the Big Bang could have been simply a transition in a continuing cycle. As soon as this universe exists, a new one emerges from it. According to this perspective, our universe is part of a larger multidimensional structure. Within this model, the idea of an eternal cycle of collapse and rebirth of the universe is put forward. However, this is not the only perspective presented in the field of cosmology. Apart from the Big Bang theory, in 1955, for example, an article appeared in NASA's Cosmic Times arguing that there may have never been a Big Bang since the universe has existed for an infinite time. In this view, the expansion of the cosmos would be non-existent, and the continuous formation of matter could give the impression of a constant expansion of the universe. Another intriguing though controversial theory comes from the world of quantum physics and string theory. Supposedly, some experiments have suggested that our universe and everything in it does not actually exist. In simple terms, what we perceive as a visible universe could simply be a flat hologram projected onto a sphere. Therefore, there is a possibility that our reality is a result of a higher simulation. While this may sound like the plot of a fanciful science fiction movie, it can be connected to the Kardashev scale. The scale is used to measure the level of development of a civilization according to its ability to use energy. If there were a Type 3 civilization capable of fully harnessing the power of an entire galaxy, it could have created a perfect simulation. However, finding out the truth in such a scenario is a very complicated matter. The possibility that we live in a simulated reality raises profound philosophical questions. If our universe is a simulation, what does that mean for our understanding of consciousness, existence, and free will? Are we merely advanced algorithms, our experiences predetermined by the parameters set by our creators? Or do we possess true autonomy within the bounds of this artificial construct? This line of thinking intersects with theories of panpsychism, which suggests that consciousness could be a fundamental aspect of the universe, much like space and time. In a simulated universe, the nature of consciousness could be entirely different from our current understanding, potentially existing as a form of complex data processing by advanced computational systems. Moreover, considering the potential for a multiverse, where numerous parallel universes exist with varying laws of physics, adds another layer of complexity. Each of these universes might have its own unique history, developmental pathways, and potential for life. This brings us to the anthropic principle, which posits that we observe the universe the way it is because if it were different, we wouldn't be here to observe it. In other words, out of the myriad possible universes, we find ourselves in one that supports our existence. This principle could be used to explain the fine-tuning of constants and conditions necessary for life as we know it, further complicating the debate between a designed universe and one born out of random chance. The study of dark matter and dark energy, which together constitute about 95% of the total mass energy content of the universe, also challenges our understanding of cosmology. Dark matter, which does not emit, absorb, or reflect light, interacts with visible matter through gravity, influencing the structure and behavior of galaxies. Dark energy, on the other hand, is thought to be responsible for the accelerated expansion of the universe. Understanding these enigmatic components is crucial for a comprehensive cosmological model, and their elusive nature fuels speculation about their origins and properties. Recent advancements in technology and observational methods, such as those provided by the James Webb Space Telescope, have significantly enhanced our ability to probe the universe's earliest epochs. These tools allow us to peer back in time, almost to the moments following the Big Bang, providing unprecedented insights into the formation and evolution of galaxies, stars, and planetary systems. However, each new discovery often raises more questions than it answers, highlighting the dynamic and ever-evolving nature of cosmological research. Astrobiology, the study of life in the universe, further complicates our understanding of cosmic origins and development. The search for extraterrestrial life, whether microbial or intelligent, drives much of the current exploration of Mars, Europa, and exoplanets in habitable zones around other stars. Discovering life beyond Earth would profoundly impact our understanding of biology, evolution, and our place in the cosmos. It would suggest that life is a common outcome of cosmic processes, potentially thriving in a multitude of environments under varying conditions. In conclusion, the ongoing debate about the origins and nature of the universe is far from settled. The Big Bang theory, while widely accepted, is continually tested by new observations and alternative theories. The discovery of early massive galaxies, the potential existence of a multiverse, and the mysteries of dark matter and dark energy all contribute to a complex and fascinating picture. As technology advances and our observational capabilities improve, we will undoubtedly uncover more about the cosmos, leading to deeper understanding and perhaps even more profound